Everyone switch on video. Yes, Bhavya, can you explain?
Yes, ma'am.
Yeah.
So, at 19 centimeter, a real magnified image is formed, and the object is placed at 21 centimeter. A real
Real
diminished
diminished
image
images formed.
is formed. So, when the object is placed between the center of curvature and the focus, a real magnified image is formed. And when the object is placed beyond the center of curvature, then a real and a diminished image is formed. So, uh, like we have 19 centimeter real magnified and a 21 centimeter real diminished. So the center of curvature must be at 20 centimeters, and we know that uh, radius is equal to 2 into focal length. So
Yes,
it's
right.
20 by 2. That's 10.
10 centimeter. Yes, it is an MCQ question. It is 19 centimeter. When we place approximate, they have asked, not the exact one. So we are considering as a whole numbers. So 19 centimeter, that means when we keep place object between C and F, we will get the magnified image. And when we place beyond C, any object beyond C, we will get the diminished image. So 19 centimeter is less than C and 21 centimeter is beyond C. Distance, the whole number distance between them is 20, we can consider. So there might be the value, C will be in between 90 to 21. 19 to 21, anything between 19 to 21 is a center of curvature. So approximately we will consider the whole number, that is 20. So 20 centimeter is the center of curvature. So C to P distance is R, radius of the curvature. So R will be 20 approx. And then if R is 20, the focal length is half of radius, that is 10 centimeter. Okay. Then 11th question. A student focused the image of a candle flame on a white screen using a convex lens. He noted down the position of candle screen and the lens as under. Position of candle is 12 centimeter, position of convex lens is 50 centimeter, and position of screen is 88 centimeter. I'll copy this question. F cannot be 19. This question. Okay, let me check this question. So here I told you it's experimental positions. It is a meter scale. Start from 0 to 100. So at 12 centimeter, position of candle is 12 centimeter. That means at 12 centimeter, candle is placed. At 50 centimeter mark, lens is placed. Position of the convex lens is 50 centimeter. That means at position of 50 centimeter, we have placed the lens at this position. And then the screen is at 88 centimeter. So 88 may be here. At 88 centimeter, you will get the screen has been placed. So this is the object. Image is formed on the screen. So here is the image formed. And this is lens, convex lens. So image is formed here. This is the candle image will be formed here. Now what is object distance? Object distance, lens has a optical center. So distance from this to this is object distance U. So which is equal to 50 minus 12, which is 38 centimeter. And here, this is image distance. V is equal to 88 minus 50, that is 38 centimeter. So this means object distance and image distance are equal. This means where the object is placed.
At 2F.
At 2F. So object is at 2F1, which is equal to 38 centimeter. So therefore F1 will be half of it, 38 by 2, which is 19 centimeter. So focal length is 19 centimeter. Where will the image be formed if he shifts the candle towards the lens at a distance of 31 centimeter? So here now he has placed at 31 centimeter if the candle is shifted. So that means what is the distance now? 19 centimeter. What is the focal length? 19 centimeter. Now object is at 19 centimeter. So where will be the image formed?
Infinity.
Image will be formed at infinity. When the object is at focus, image will be at infinity. So image will be at infinity. And what will be the nature of the image formed if he shifts the candle towards the lens? So again towards the lens now. So what is the nature? So nature will be virtual and erect. Virtual and erect image. Okay. Any other doubt? Any other doubt anyone has still?
Ma'am,
Yes.
can you show me the question paper once? I'm on question number 90. Object distance is 12 centimeters.
What object is?
Object is kept at a distance of 12 centimeters.
Yeah. When the object is at a distance of 12 centimeter from it. So U is 12 and the HI is, magnification is 2/3. So real image is 2/3 of the size of object. That means HI by HO is 2/3. But it is a real image they have told. That means it is minus 2/3. So this is minus 2/3. M is minus 2/3. And it is a convex lens. So plus V by U is equal to minus 2/3. So find the relation between them. So V and U is already given. Find the image distance. Okay. All these are board questions. Okay. Any other doubts you have still? Fine, then we will continue with the next chapter, acid, base and salt chemistry.
Ma'am, is there any test this weekend?
Oh yeah, Sunday you have maths test, no?
Which one?
All 3 chapters. You have Monday maths exam in school. You have in school you have Monday maths exam. So here also the same 3 chapters test on Sunday. First three chapters. Yes, real numbers, polynomials, and this one, linear equations. And is that told the deleted portions will be there or not?
They will not be there.
They will not be there, right?
Yes, ma'am.
Okay. And Baga, in your school?
We don't have any idea about tests right now.
No, not tests. What about the deleted portions? What they have told?
Nothing. They're teaching us the whole thing. I mean,
Yeah, they will teach whole thing. That's not a problem because every school is teaching the whole thing. They are not leaving any of the part. Thing is, in exams when they are taking, will they take those parts?
In maths, they haven't clarified anything about it yet.
Okay. Fine. Fine. So starting with the next chapter, acid base. We had to finish it faster so that we can start the next chapters. The third chapter we need to start. Okay, our reproduction we have to start first. Acid, base, and salt. So acid, base, and salt in that first acids and bases. Exam is on Tuesday. I know that one. Fine. Acids. Definition of acids first. Acids are those substances which on dissolution in water produce H plus ions, hydronium ions. Okay. Acids are those substances which on dissolving in water dissociates to form H plus. Here you have to write aqueous ions, or you can write H3O plus, that is hydronium ions. Rohit, what's the problem?
Nothing. I forgot my camera was on. Sorry.
That's not a problem, but you have to sit at the class timings.
Sorry, ma'am.
Sit and listen because revisions are going on. So these revisions, I don't think so immediately I will take it. So earlier, whatever the chapters we have done, after that, again, after completing 3-4 chapters, we will do revisions of those chapters. So this, again, the revisions will come at the end. Again, in between, it's not possible to take all those because we need to finish the portion also. Actually, we are lagging much behind, as my other batches, only 2 to 3 chapters left out. All other chapters already done. You are much more lagging behind in science. Okay. So acids are those substances which on dissolving in water, they dissociate to form H plus ions or H3O plus ions. So here when you are writing H plus hydrogen ions, at that time you have to write this aqueous because this H plus ions dissolves in water and form hydronium ions. Any one of this you have to write. If you are writing H plus ions, write aqueous. If you are writing hydronium ions, show H3O plus relation. It's clear? So HCl, when dissolves in water, it forms H plus and Cl minus. This H plus combines with other molecule of water and form H3O plus. This is hydronium ion. Okay. So names of acids.
Sulfuric acid, H2SO4.
Yes, sulfuric acid, H2SO4. Hydrochloric acid, HCl. Nitric acid, HNO3. Carbonic acid is H2CO3. Phosphoric acid, H3PO4. Acetic acid, CH3COOH. Formic or methanoic acid, HCOOH. So these are the acids symbols you need to remember. Formulas you have to remember. Then what are bases? What is the definition of base?
Ma'am, bases are those substances which, when dissolved in water, dissociate to form OH minus.
Hydroxide OH minus ions are those substances which, on dissolving in water, gives OH minus, that is hydroxide ions are formed. NaOH produce Na plus plus OH minus. KOH produce K plus plus OH minus. Lime water, calcium hydroxide produce Ca2 plus plus 2 OH minus. So all metal hydroxides and all metal oxides are basic. All metal hydroxides and metal oxides are basic. Acids are formed from nonmetals and all bases are formed from metals. Only one exception. What is that? What is the exception?
Ammonium hydroxide.
Ammonium hydroxide, right? Ammonium hydroxide, which is made from non-metal. NH4OH. Here one question is asked, 1 mark question. Although ammonia is neutral, gas is neutral, yet when it is dissolved in water, it changes the color of litmus. Give reason. Ammonia gas is neutral in nature, but when dissolved in water, it changes the color of litmus paper. Give reason.
Ma'am, mic is muted.
Yes, Janvi? Is there or gone? Just now she messaged me.
Yes, ma'am. Actually, it will give out OH minus ion, so it is basic, and thus it will change its color, I guess.
Yes, it changes so that you have to write the reaction. Ammonia, when dissolved in water, it will form ammonium hydroxide, NH4OH. So you need to show the reaction. When ammonia, NH3, yes, right? NH3, when dissolved in water, first it will form NH4OH, ammonium hydroxide. Further, in water, it will separate to form NH4 plus and OH minus. So due to production of OH minus ions, it will show basic properties. And therefore, it changes the red litmus to blue. red litmus turns blue. Is that clear? Acid-base indicators. Further is acid-base indicators. What do you mean by acid-base indicators? What are acid-base indicators? The substances,
Which helps us distinguish between acids and bases.
yes, which helps in distinguishing acids and bases, which gives different colors or different odors to test whether the given substance is acidic or basic in nature. Helps in distinguishing acidic or basic nature of substance by either changing color or by changing odor. So by changing color, those are called color indicators, color acid-base indicators, and by changing odor, those are called olfactory indicators. So color changing in that litmus, natural color, color in acid, color in base. In that litmus, natural color is purple. In acid, the color changes to red. In base, color changes to blue. Turmeric, original color yellow. In acid,
No change.
no,
No change.
no change. In base,
Reddish brown.
red or reddish brown. Then methyl orange. Original color, name itself, orange. In acid,
Red.
Red.
red. In base,
Yellow.
yellow. Then phenolphthalein. Original color, colorless, transparent. In acid,
Colorless.
it's remain colorless, and in base it changes to
Pink.
pink. Alkaline phenolphthalein, color of alkaline phenolphthalein,
Pink.
Pink.
yes, it's pink. Alkaline, that means alkali is added to it. Alkalis are what? Base. In a base, phenolphthalein changes color to pink. So alkaline phenolphthalein has the color pink. It is used for testing acid. Because normal phenolphthalein remain colorless. It was colorless and remain colorless in acid. So we cannot detect actually acid and neutral solutions. So to test acid and acidic and neutral behavior that can be used, it uses alkaline phenolphthalein. So in the phenolphthalein, 2 to 3 drops of base is added, then that we call as alkaline phenolphthalein. So it changes to pink color. The full bottle will change to pink color. And now few drops of that phenolphthalein taken into the test tube, and then if acid is added, it turns colorless. Okay. Olfactory indicators. What are the examples of olfactory indicators?
Vanilla.
Vanilla
Onion
essence,
extract.
clove oil,
Onion extract.
clove oil, onion extract. So all of them has the same change. That is in acid, no change in the odor, but in base, the odor vanishes. Olfactory indicators, those have the specific peculiar smell. So that smell remains same if the acid is added, but the smell dilutes or vanishes when base is added to them. Okay. Done?
Yes, ma'am.
Okay. Then is common properties of acids and bases. What are the properties they have in common? Both of them are corrosive, inflammatory. They're highly corrosive and highly inflammatory. That means they catch fire very easily. And whichever the substance they fall, they chemically react faster. They react with that chemical faster. Even on the human body, it reacts very quick, very fast. It burns the skin completely. Okay, imperable problem creates when the acid falls.
They don't show their chemical properties until they're dissolved in water.
Yes, they show their acidic or basic behavior, respective behaviors, that is acidic or basic properties, they will show only when they are dissolved in water. Because the reason is, what is the reason behind it?
Acids show acidic properties only when free H plus ions are when they
Yes,
dissociate to form free H plus ions, and
yes.
bases
Bases when they are OH minus ions,
OH
right?
minus.
So acids' acidic properties is completely dependent on free hydronium ions, that is H plus ions, hydronium ions. So when the hydronium, whichever the substance has given out that free H plus ions, all those shows acidic properties. So acidic properties, that is all the chemical properties of acids, or even these indicators. So indicators can detect those. So those acidic behavior will be seen only in presence of free H plus ions, hydronium ions. So therefore, and this is possible, that is the hydronium ions will be free only when these substances are dissolved in water, not in any other cases. So therefore, acid shows acidic behavior only in presence of water, because in presence of water, the acid dissociates to form free hydronium ions, and free hydronium ions are responsible for acidic nature. Same thing for bases. Bases, in presence of water, bases dissociates to form OH minus ions, and basic properties are completely dependent on free OH minus ions. Two sentences you have to write, mandatory sentences. So write down why they show acidic or basic properties only in presence of water. Why acids show acidic behavior only in presence of water. In presence of water, acid dissociates to form H3O plus. Free H3O plus is responsible for acidic behavior. Okay. These two sentences are utmost important. That is a formation of these ions when only in presence of water, and these ions are only responsible for acidic behavior. Free H3O plus ions. Same thing you can write for bases. Is it clear? You have written for bases? Have you written for bases?
Yes, ma'am.
Second common property? What is the second common? Now here again another question, that is alcohol and glucose when dissolved in water do not show acidic properties, although they consist of hydrogen or hydroxide ions. Although they consist of hydrogen. Can you tell the reason? Glucose and alcohol, though consist of hydrogen, do not show acidic properties.
Ma'am, in water they don't dissociate to release H plus ions.
Yes, right. And H plus ions are responsible for acidic properties. Proper answer, you have to write it down. So why they, what is the reason? So what is the H plus ion is doing? So you have to write that. So they do not dissociate to form H plus ions. Now why H plus ion is necessary, that also you have to mention. Okay. So H plus ions, that is hydronium ions, are responsible for acidic behavior, and this glucose or alcohol when dissolved in water do not produce hydronium ions. So therefore, they do not show acidic properties. Done?
Yes, ma'am.
Okay. And then another example, which gases, name the gas released when sulfuric acid is added to sodium common salt. Which gas is released when sulfuric acid added to sodium common salt?
Hydrogen chloride.
Hydrogen chloride gas. So what is the change will be seen when it is tested with dry litmus paper and wet litmus paper? What changes will be seen when the released gas is tested with dry litmus paper and wet litmus paper?
No change in dry litmus paper. In wet litmus paper, it changes the color
From which to which?
from blue to red.
Blue to red. Reason?
Because in dry, there's no water molecule present in dry litmus paper, due to which H plus ion is not produced, which is responsible for acidic behavior.
Yes, right, exactly. So dry litmus paper, and the gas is also dry and the litmus paper is also dry. So no acid shows acidic behavior only in presence of water, as they form hydronium ions, which are responsible for, in water they form hydronium ions which are responsible for acidic properties. So therefore no change will be seen in dry litmus paper, but in wet litmus paper hydrogen chloride gas dissolves to form hydronium ions which are responsible for acidic behavior, start showing acidic properties and changes the color of blue litmus paper to red. Clear? So this is all about the presence of water. Then second, both of them, acids and bases, both conduct current. So second property is acids and bases both conduct current. Reason? What is the reason?
Ma'am, when they dissolve in water, they dissociate to form free ions, which are responsible for conducting current.
Yes, right. Conduction of current in aqueous or in a liquid solution is due to presence of free ions. Acids and bases, when dissolved in water, they produce free ions, due to which they can conduct current. Okay. Conduction of current in aqueous solution or molten solution is due to presence of free ions. And acids or bases, when dissolved in water, forms free ions, due to which they conduct current. Okay. Then dilution of acids and bases. Precaution need to be taken while diluting acid or base. What is the precaution need to be taken?
Ma'am, we should always add acid drop by drop in water, not water into acid.
We need to add acid or a base drop by drop into water for dilution, for diluting them, not the reverse. That is, water should not be added to acid or a base. Otherwise, the problem is this reaction is highly exothermic reaction. So due to the evolved heat energy, the acid or a base gets converted into vapors, and in gaseous state they can cause harm to the people standing nearby or in that room, damages the eyes, and even to that temperature the container may break and the solution spurt out, causing damage to the people standing nearby. It's clear? What happens to hydrogen ion concentration when acid is diluted?
It decreases.
It decreases. And what happens when excess base is added to the base, to hydrogen ion concentration?
Increases.
Hydrogen ion concentration, I've asked.
Decrease.
Decreases.
Or decreases.
H plus ion concentration will decrease. OH minus will increase. All the acids consist of hydrogen ions as well as hydroxide ions. But it is acidic because H plus ions are more than OH minus ions. Clear? And all the bases, although consist of hydroxide ions, but along with that they also consist of H plus ions. But the number of OH minus ions are more than number of H plus ions. So therefore it shows basic behavior. Is that clear? So every solution, every true solution have both H plus and aqueous solutions, not true solutions. All aqueous solutions have both H plus and OH minus ions. So depending if they are both equal, then the solution is neutral. If H plus ions are more than OH minus ions, then that solution is acidic. If OH minus ions are more than H plus ions, then that solution is basic. Clear?
Yes.
So aqueous solution, H plus ion concentration is equal to OH minus ion concentration, then the solution is neutral. Further, H plus ion concentration is greater than OH minus ion concentration, then the solution is
Acidic.
Acidic.
acidic. And if H plus ion concentration is less than OH minus ion concentration, then the solution is
Basic.
basic. Chemical properties. First one, acid reacts with metal. First is reaction with metal. It will form
Metal salt plus hydrogen.
yes, right. Metal salt plus hydrogen gas is given out. Na plus 2HCl. 2Na plus 2HCl form 2NaCl plus H2. Calcium plus sulfuric acid gives out calcium sulfate plus hydrogen gas. Zinc plus hydrofluoric acid gives out ZnCl2 plus H2. Done. Base plus metal. Base plus metal. All the metals can react?
No, ma'am. Only three of them.
Which of them?
Zinc, aluminium, and
Lead.
Lead. Right. So base NaOH combines with zinc. It will form Na2ZnO2 plus H2. NaOH plus Al gives out NaAlO2. So name of this compound is Na2ZnO2 is
Sodium zincate.
sodium zincate. And this is sodium
Aluminate.
aluminate. Nitric acid. When metal reacts with nitric acid, hydrogen gas is not produced. Give reason. Important question. Hydrogen gas is not evolved when any metal react with nitric acid. What's the reason? Can you tell the reason of this? Yes, Rohit.
Mom, it is a strong oxidizing agent, so it oxidizes to form water.
Oxidizes hydrogen to form water. So nitric acid is a strong oxidizing agent. Which oxidizes evolved hydrogen to form water. So, but there is some exception. Some metal can react with nitric acid, very dilute nitric acid, to form hydrogen gas. What are those?
Magnesium and manganese.
Magnesium and manganese. Magnesium and manganese, Mg and Mn, are the two metals. There are few more, but these are the known metals. When react with a very, very dilute nitric acid, that is 5% dilute nitric acid, hydrogen gas is evolved. Okay. Most commonly asked equation is Zn plus NaOH. Zinc reacts with sodium hydroxide. Most commonly asked that reaction. Then second one is acid reacts with metal carbonates or metal hydrogen carbonates. Metal carbonate or metal hydrogen carbonate or hydrocarbonate reacts with acid. What it will form?
Metal salt, water, and carbon dioxide.
Metal salt, carbon dioxide, water and carbon dioxide or water. Carbon dioxide evolves out. Sodium carbonate plus HCl gives NaCl plus H2O plus CO2 gas is given out. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Calcium carbonate, that is limestone, marble, chalk powder, when combines with hydrochloric acid, produces calcium chloride plus water plus carbon dioxide. Test of carbon dioxide.
Get a burning matchstick near the gas, it will extinguish the fire.
Yes. It
Turn
extinguishes burning matchstick or burning candle. Second,
slime water milky.
turns lime water milky. Third is brisk effervescence. Brisk effervescence. Turning lime water milky reaction. Carbon dioxide passes through lime water, that is calcium hydroxide. It will form calcium carbonate plus water, which is milky, because it will form suspension. Calcium carbonate in water is a suspension. It won't dissolve. And when excess carbon dioxide is passed through the same solution, then the milkiness disappears due to formation of calcium hydrogen carbonate. It will be colorless. This is a colorless solution. Okay, so these two reactions, remember. Then third type of a reaction with base. Acid plus base form salt and water. HCl and NaOH combine to form NaCl plus H2O. So in this case, actually this reaction is called neutralization because H plus ions of acid and OH minus ions of base combine to form water. They combine. There are no free H plus or OH minus ions. So therefore they do not show any acidic or basic properties. Clear? Is it clear?
Ma'am.
Okay, so this is neutralization reaction. Acid plus metal oxide form salt and water again. HCl plus calcium oxide forms calcium chloride plus water. Copper oxide plus hydrochloric acid forms copper chloride plus water. So here also the formation of water explains that metal oxides produce OH minus ions which combine with H plus ions of acid to form water. Therefore, metal oxides are basic in nature. These are all chemical reactions you have to learn for acidic and basic properties. Done. The next left out is pH indicator, universal indicator, pH scale, and salts. So that we will finish on Friday. Okay. Friday you have a holiday? School? I think so. Friday is a holiday. Yeah, I guess because Karnataka that is a holiday. Mahalakshmi Puja. You have Mahalakshmi Puja on Friday, so Friday might be the holiday. Second Savan Friday. Okay, fine. So we will start now. Till this, any doubt? Any doubt till this part?
Ma'am,
Yes.
what is basicity?
Basicity, that is basic properties. Basicity measuring, that is how many OH minus are needed to neutralize any OH plus ions of acid. So that is called basicity of hydrogen. Basicity of acid we call it as, and acidity of basis we call it as. So basicity of acids means how many H plus ions are responsible for neutralizing OH minus ions of that particular base. Now it is NaOH is there. To neutralize NaOH, how many H plus ions are needed?
One.
One only. So it's, and if it recombines with HCl, so HCl is one H plus is given out, so its basicity is 1. So 1 H plus ions will combine with 1 OH minus ion. So basicity is 1. Of basicity of acid we call it as, and acidity of bases we call it. Okay, so that is how many H plus ions are responsible for neutralizing any base, and how many OH minus are responsible for neutralizing any acid is called its acidity. Efflorescence means the some of the salts has the property of losing water when they are exposed to air. So those are called efflorescence. So those are hydrated salts. So when hydrated salts are left open, exposed to air, they have the property, tendency to lose water. So that is called as efflorescence. Deliquescent salts are also there. So those are the salts which absorb water when exposed to air and become wet. And brisk effervescence, that is a fizzing effect. When you add ENO into water, or you add as this one baking soda and vinegar together. So what you will see? The foam-like structure start forming immediately. Or you open a cold drink bottle. What you see? That means it's fizzing. So that is called brisk effervescence. So whenever you add ENO, you have seen the structure most commonly. ENO, when we add into water, we will see immediately, we will hear the fizzing sound. Fizzing sound, we can hear it. And you also see that is a foam-like structure is formed over it. So that is called brisk effervescence. Clear? Any other doubt? Doubts are there? If a doubt is there, is yes. Or doubt is not there, it's there, yes. Couldn't get what your answer is. No, okay. Any doubts till this part? Fine, then we'll start maths.